Hi everyone, you're welcome back to Explore Insights. In this video, I'd like to teach you on how to convert octal number system to hexadecimal number system. It's a bit trickish, but I'm going to put you through. And I believe you'll find this video helpful. Do well to watch to the end of this video. If you're just joining for the first time, don't forget to subscribe to this channel. So without any further ado, let's quickly dive in. Talking about octal to hexadecimal conversion, we really need a mediator. Now, what do I mean by mediator? It means we have to convert octal to decimal before achieving the hexadecimal, or we convert octal to binary before achieving the hexadecimal value. Whichever method is okay. However, using the binary mediator is quite easier than considering that of the decimal as a mediator. So let's quickly start with an example. So we'll consider example 1. Now in example 1, we are asked to convert 657 in base 8 to hexadecimal. The steps we are going to take is to first of all bring out this value which is in octal system. And the next step is to involve our mediator. So in this case, our mediator will be binary. And after that, we move over to hexadecimal. So how do we go with this? Okay, so let's start. If I'm moving from octal to binary, we'll consider 8 as 2 raised to power 3. So it means I am going to convert each of this value to binary. And if you watch my previous video, you will see how I explain in more details about these steps. But I'm going to make a few recap on this in this video. But for better understanding, please do well to watch the video before this one. So, like we said, the octal value 8 has digits between 0 to 7. So it leaves us with 4, 2, 1. It means within this range, we can have a value. So we are using this trick to convert any given value we have in our question. What do I mean? It means I'm going to use 4, 2, 1. So now we have 2 raised to power 3, and the highest value we can take is 2 raised to power 2, 2 raised to power 1, and 2 raised to power 0, which leaves us with 4, 2, 1. So it is this 4, 2, 1 I'm using here. How do you better understand this? Now we have 4, 2, 1. I'm going to find out which of this value can make up 6. And if anyone does, I'm going to turn that on, or else I'm going to off it. So for 6, we have 4 and 2. If I take 4 plus 2, it's going to give me 6. So I'm going to turn that on. Since I didn't use 1, it will be 0. Remember, it is 3 digits in a set. That is the relationship between octal and binary. Now let's move over to 5. For 5, what can I sum up here? It means if I take 4 and 1, I can have 5. So it means I'm turning on 4 and 1. But since I didn't use 2, I'll put that as 0. The same thing for 7. What am I going to turn on? Definitely it will be everything here. 4 plus 2 plus 1 will give us 7. So everything here will be turned on. So at this point, we've gotten our binary. Having actualized the binary, the next thing we have to do is to convert this binary now to hexadecimal. So what do I mean? We are moving from 2 now to 16. Now the relationship 2 raised to power 4. So what does this tell us? we're going to have 4 digits as a set. If I take that, we have 1, 1, 0, 1, 0, 1, 1, 1, 1. Now, I want to take 4 as a set. I have to move from right to left. And then pick my 4 for 4 digits in a set. From here to here, 4 digits in a set. However, in this case, I don't have other 3 digits. So at this point, I will introduce padding. The padding I'm going to put will be zeros, 3 zeros, because 0 have no significant effect. So this will set it up as 4 digits in a set. This is introducing padding of zeros. Now let's see what we have. Now in this other scenario, if you check my subsequent videos, I made you to understand that having 2 raised to the power 4, we have to only use 2 raised to the power 3, 2 raised to the power 2, 2 raised to the power 1, and 2 raised to the power 0. Now 2 raised to the power 3 will give us 8, 2 raised to the power 2 will give us 4, 2 raised to the power 1 will give us 2, 2 raised to the power 0 will give us 1. And when we sum this up, it will be 15. Remember, hexadecimal ranges from 0 to 15. So we'll be using this in the next step. So what am I going to do? I'm just going to put 8, 4, 2, 1. 8, 4, 2, 1. 8, 4, 2, 1. Now the next thing to check is, at what point did I get 1? It means at what point was it turned on? Now if it's turned on more than once, I'm going to do a summation. So let's take the first one. I'm considering this value. Now we have 1, 1, 1, 1. So it means everything here was turned on. Now it means 8 plus 4 plus 2 plus 1 will give us 15. What is the representation of 15? It is actually F. So let's move to the next one. That means this next set. So we have 1, 0, 1, 0. Now we have 8. This one was turned off, so we will not use 4. We have 1 here, which is representing 2. And this one was turned off. So we are not using the 4 and 1. We're only using 8 and 2, which is representing this one and this one. So 8 plus 2 will be 10. In hexadecimal form, 10 is what? A. Now let's move to the next value. We have 0001. So it means 8 was turned off, 4 was turned off, 2 was turned off, but we have 1. So at the end of the day, we have only 1. So we have 1 here. So now, to better represent this, it means that we are going to have 1AF in H. So that simply tells us that 657 in base 8 will be 1AF in hexadecimal form. How about if I consider example 2? Now in example 2, I want to look at a value with decimal points. Now we are asked to convert 253.6328 to hexadecimal. So find X. So let's consider this example, 253.632 in octal system, and we are asked to find the value of X in hexadecimal form. The first thing I'll do is to spread out this value, 253.632. Now remember, we are going to look for first the mediator value before converting it to hexadecimal. The first thing we're going to do is to convert this value to binary, which is the mediator, and from there we convert from binary to hexadecimal. So let's start immediately. So I'm moving over to the mediator. 2 raised to the power 3 will be 8. So it means we have to use 4, 2, 1. Okay, like I explained in the previous one, what we have here. Okay, so I'm going to put 4, 2, 1 in each, 4, 2, 1 in 4, 2, 1, 4, 2, 1. 421, 421, 421. Okay, so this is just to guide us in a fast calculation. So now 2 can be found here, but we are not going to use 4 and 1. So we put that as 0, 1, 0. What about 5? If we add 4 and 1, it's going to give us 5. So we'll turn that on, 1, 0, 1. And for 3, we have 2 and 1. So 4 will be turned off, and we have 1, 1. Dot 6 will be 4, 2. So we will turn that on and put this 0. 3 will be 2, 1. So we have 0, 1, 1. And then 2 will be 0, 1, 0. The next step we have to do is to convert this given value to the hexadecimal form. Okay, so now we have to put this out. So we have 0, 1, 0, 1, 0, 1, 0, 1, 1, dot 1, 1, 0, 0, 1, 1, 0, 1, 0. And like we said, we have to group it as a set. That means 4 digits in a set. So we go towards left to right in this angle, and for this one from left to right. For this angle, right to left. For this angle, we go right to left, whereas for this, we go left to right. So with that, we're going to start grouping. Okay, so it means I'm taking from this point 4 digits, and here to here another 4 digits. So if you look here, I'm going to have 0, so I can pad with extra 3 zeros. So that is padding. I'm going to pad that. And let's move from here to here. 4 in a group, here to here, 4 in a group. And for this 0 is not relevant because this is the decimal place. So I'm not going to put padding here because it's not relevant. Okay, so let's continue with what we have. So let's check 1011. Remember, at this point, we are dealing with mediator and hexadecimal. So we are going to put 8421, 8421, 8421, 8421. So if you check that, if we sum that, we have 1 is on here, which is 8, and 1 is on here, which is 2. So 8 plus 2 will be 10. And remember, 10 is what? A. Let's check this one. 1 is here, 1 is here, 1 is here. What is its relevance? 1 is here, 1 is here, 1 is here. It means we have 8, 2, and 1, but 4 was turned off. So 8 plus 2 plus 1 is 11. So in this case, 11 will be B in hexadecimal form. Remember to put the dots, and we move to the next value. We have 1100. So that means we have 1 here, 1 here. So 8 plus 4, which is 12, because we don't have any value to use here. So 2 and 1 will be 0. So we have 12, and 12 in hexadecimal form is C. Let's move to the next set. So we have 1101. So we have 1, 1, which is 8, 4, 0, which is 2. We are not using this, and 1. So we have 8 plus 4 plus 1, which is 13. And 13 is D. So at the end of the day, our value, which is 253.632 in base 8 will be AB.CD in hexadecimal form. So now, if they're asking us what is the value of X, X will be AB.CD. So let's continue with another example. Let's say we have example 3. And this example 3 is actually a question, a past question. So we have if 1, 1, x, 1, y in base 8 is 1 to 6, 9 in base 16, then the values of x and y is, so we are giving different options. A, 3 and 1, B, 5 and 7, C, 7 and 5, D, 1 and 5. So what does that mean? What will be the value of x and what will be the value of y? So how do we solve this? Just like what we did in example 1, 2. So we'll take that to solve this given problem. So the first thing to do is to bring out this equation. And now I'm going to start with the known value. This is the known value. Now we have 1 to C9 in base 16. Remember, C in this case is 12. So since I'll be converting the hexadecimal to 8, so that at the point I'll be having both bases on both sides. And if I'm able to equivalent both bases on both sides, it means I can find the value of x and y. So first thing to do is to convert the hexadecimal to binary. And then from binary to octal. So all I have to do is to quickly recap for 16. We have 2 raised to power 3, 2 raised to power 2, 2 raised to power 1, 2 raised to power 0. So that will be 8, 4, 2, 1. So I will relate that here. 1, 2, C9. I can make this as 12. So take note of that. This is 12. Okay. Now, 8, 4, 2, 1. 8, 4, 2, 1. 8, 4, 2, 1. 8, 4, 2, 1. So in this case, wherever we find the value, we'll put 1, else we will write 0. Now, looking for 1 here, it means yes, we can get 1 here. Then 8, 4, 2 are not needed. So that will be 0, 0, 0, 1. Now, let's look for 2. Can 2 be found here? Yes, exactly. So 4, 8, 4, and 1 will be turned off. Just 2 that we can find will be turned on. Now, for our C, we say C is 12. So what will give us 12 is 8 and 4. So it will be turned on, while 2 and 1 will be turned off. Now, for 9, what will sum up to give us 9? 8 and 1. So it means 1, yeah, 0, 0, 1. Because 8 plus 1 will give us 9. So since we have done this in the binary form, the next thing is to convert this binary to octal. And for octal, we say it's 2 raised to power 3, which goes with 2 raised to power 2, 2 raised to power 1, 2 raised to power 0. Because this will give us 4, 2, and 1. 4 plus 2 plus 1 is 7. And we know in octal, 7 is the highest digit in octal number system. So we are going to consider first arranging this as 0, 0, 0, 1, 0, 0, 1, 0, 1, 1, 0, 0, 1, 0, 0, 1. Now, what is our next rule? Our next rule is we are going to, first of all, we're going to consider 3 digits as a set. and we will move from right to left. So I'm going to take 3 digits as a set, 3 digits as a set, 3 digits as a set, because I'm dealing with octal, 3 digits as a set, 3 digits as a set. Now, if you look at this point, we have only 1, but we need 3 digits. So what am I going to do? I'm going to introduce a padding of 0. So introducing 2 0, we'll put it as a set. However, since at the end of the day, we are going to have 0, so it's really not significant. Now, let's consider what this value will be. First, we have to put in the 421. So 421, 421, 421, 421, 421. Okay, 421. This will still give us 0. So let me just write this one as 0. Now let's see. This and this, what was turned on? It was just 1. So it means I'll have 1 here. Now for this one, 0, 0, 0, 0, 0, 1. So it means I just have 1 here. Now 0, 1, 1, it means this was turned on, this was turned on. So 2 plus 1 will be 3. 0, 0, 1, this one just was turned on, so we have 1. And 0, 0, 1, this one was turned on, so we have 1. Remember, this is from binary to octal. Now, let's recap. This was the given question, and this was in base 8, whereas this was in base 16. The thing we have to do is to convert this to base 8, so that when we equate it, being of the same base, it will be easier to get the value for x and y. So let's record that value, 1, 1, x, 1, y in base 8. When we converted 1 to C9 in base 16 to base 8, we have 1, 1, 3, 1, 1, which is in base 8. Our main value will be that what is the value of y? So if we look through, like considering here and considering here, we can tell that y is actually this value and x is actually this value. Because since they are of the same base, it's easy to locate the unknown values from the given values. So now at this point, our x and y is 3 and 1. So let's go back to the option. So we have 3 and 1, 5 and 7, 7 and 5, 1 and 5. So it can be seen that option A is correct. So we'll give our answer as option A. So guys, we've come to the end of this video, teaching you on how to convert octal to hexadecimal number system. If you're just joining us for the first time, do well to subscribe to this channel. And don't forget to hit the like button so this video can be recommended to those out there that really needs these calculation tips. Do well to watch our subsequent videos, as this will take you through the whole knowledge of number system conversion. So I'll be signing off now. Do have a nice time. Bye.